Hi students, welcome back. Today we are going to look at the binary search problem. This is a very important problem in search algorithms which will be used in solving many other problems as well. So let's head to the problem statement first. So the problem statement says we are given an array of numbers which is sorted in ascending order and an integer target. We have to find the index of this target in the array if it exists. Otherwise, we have to return a -1. So the important thing is you must write an algorithm in order of log n complexity. Okay. So given array like this, if we are to find 9 in this, 9 is at this position if you look, which is at 4. So the output should be 4. Okay. If the given array is this thing and the target is 2, target doesn't exist in this array. So we return -1. Okay. And the other condition we are given is all the numbers are unique. Numbers are sorted in ascending order. Okay. So let's look at the solution with an example. Let's say we are given this array and we are looking for 56 in this. Okay. So in binary search, the approach we will, so if we use a linear search, right, it's very easy. We go over the element one by one and we can check whether the element exists or not, which would be order of n complexity. But here what we are looking for is a order of log n complexity. So in binary search, we basically log n means you have to reduce your input into half at every step. That's when you will get the log n complexity. So to do that, what we will do is we will take two pointers, a left pointer and a right pointer. Okay. So left pointer is at the start of the array, right pointer is at the end of the array when we start. Then at every step, what we will do is we will compute the mid. So here in iteration 1, mid is 8 plus 0 by 2, which is 4. So at 4, we have 39. Okay. So the value of the element at mid is 39. Our target is 56. So we will compare 39 with 56. If 56 is greater than 39, what does that show? Our element would be somewhere on the right side of the 39. That means our element would be somewhere here, right? So what we will do is we will move the left pointer to mid +1. So our left pointer will come here. Okay. So our left pointer is at 5 now, right didn't change. Now we will again do the same. In the next iteration, we will calculate mid again. Now mid is 8 plus 5 by 2. 8 plus 5, 13 by 2, which is 6. Okay, mid is 6. Now we are at this position. So array of mid is target is greater than array of mid, which means target will be again on the right side of mid. So again we will move our left pointer to mid +1. So our left will now come here. So now left is at 6, right is at 8. So in the third iteration, 7 plus 8 by 2, mid would be 7. So our mid is also here. We compare mid with target. Mid is exactly equal to target. So we just return 7, which is the index. So we started with both the ends of the array. On every iteration, we are checking where our target is, on which side of the mid. And we are in the new iteration, we are only checking that half of the array. That is what the algorithm is. How long will we do it? As long as left is less than right. So as long as left is less than or equal to right, we will do this. The moment right becomes less than left, we will break. That means the element doesn't exist and we return -1. So let's see another example, this time a negative case. So let's say it's the same array we have and this time our target is 25. So our left pointer is here, right pointer is here. Okay, mid is 8 plus 0 by 2, 4, 39. Our target is 25. 25 is less than 39. That means 25, if it exists, it will exist on the left side of 39, right? So what we will do is, we will move the right pointer to mid minus 1. So now this is our new array, 0 to 3. Now what is the mid now? 3 by 2, which is 1. Okay. So now we are at here. Target is greater than mid. So now we will move the left pointer to mid plus 1. So now left comes here. So left is at 2, right is at 3. And mid will be 2 again. So when we are at 24, when we compare target, target is greater than the value of mid, which means we should move towards the right side of the comparison. So when we move towards the right side of the comparison, our left pointer comes here. Okay. So our left is here, right is here, and mid is also there. Both are our target is not equal to mid, and target is actually less than mid. So target should be on the left side. So in this case, what we will do, we will move right to the left side. So at this point, what happened, right became less than left. So at this point we will break, which means the element doesn't exist. So we return -1. So at every point we keep reducing the array into half, and if we keep going until left is less than or equal to right. The moment that condition fails, that means the element doesn't exist and we break. Now let's write code for this problem. Okay, so we first need a left and a right. Right is nums dot length -1. So while left less than or equal to right, what do? We get the mid equal to we could we were finding it by left plus right by 2, correct? So this one, it has a possibility of having a integer overflow because we are adding two numbers. So instead, the other approach that is followed here is left plus right minus left by 2, which is same as left plus right by 2 if you really see, but we are changing the value in the, we are doing it with a much smaller number, the division, which is why the integer overflow would be avoided. So ultimately this is also right plus left by 2, but this is a simple trick to handle that integer overflow. Okay. Now what do? If nums of mid is equal to target, okay, then return mid. Okay. Else if nums of mid, so if target is less than nums of mid, target is less than the midpoint, that means we have to move our search to the left side of the array, which means we have to change our right pointer to mid -1. Else in this case, there is only one case left, which is target is greater than nums of mid, which means our target lies on the right side of the array, which means we will move our left pointer to mid +1. And if nothing is found, it will break the loop, and right goes when the left is greater than right. In that case, we just return -1. Okay. Oh, sorry. Okay, let's run this and see. Okay, let's submit it. Yeah. So our solution is accepted. So what is the time complexity? So every time we are reducing our input into half. So it would be order of log n. Okay, we only have one loop here, and every time we are going to the half, we are reducing the input size to half, so it is order of log n. And what is the space complexity? We are not using any additional space, so it is order of 1. Okay, so that's all for today. Hope you enjoyed the problem. If you have any questions, do leave a comment. Please like, share and subscribe. Thank you.